Okay, we're going to talk about Lewis dot structures today. These are a very helpful way to us to learn to make molecules. And the first type of molecules we're going to make are ionic molecules. Sometimes people call them salt. So here, let me tell you about Lewis dot structures. So first of all, we have learned that chemistry is all about electrons. We learned about protons and neutrons, but really what chemistry is all about is the electrons. Now, according to the Bohr model, electrons are going to be placed in orbitals around the nucleus. So if you remember, just looking here, we had several orbitals around an atom, and we figured out how many electrons we had in there by looking at the atomic number. The number of electrons was exactly the same. And so in this particular case, what do we got? 1, 2, 3, 4, 5, 6, 7 electrons. This is nitrogen, actually, element number 7. However, you can see that 2 of them went in the first ring there, and then we had 5 left over in the ring past that. So that's what's going to be important, is those number of electrons in the outer ring. Okay? These are called valence electrons. Now, according to the Bohr model, if you have a whole bucket of electrons, first thing you do is you start placing them in the inner ring and then work outside. And we wrote this down in our notes, right? How many electrons we could have in each one. So if you remember here, we could put in the first ring over here, we could have 2 electrons, right? And then as we went down the line there, you could put in 8 electrons, and as you continued on down there, 18, and the fourth ring, 32. And you keep putting them in till the ring gets filled in, and then you go to the next one. So in this case, we had nitrogen, right? Nitrogen had 7 electrons. We would then go ahead and we would put in here, right, 2 of them in the first ring. That leaves us 5. And then we'd put them into ring number 2 because it can take the 5 and we'd still have room if we wanted to put 2 more in there. So in this case, the valence number would be 5. We have 5 electrons on the outside. Okay, so valence electrons, this is the important thing. The number of electrons who are only found in the outer ring. And those are the guys who are going to react with other atoms. They're what chemistry is all about. Okay, now the periodic table was organized to make this very, very easy. We don't have to keep playing this game of filling in how many electrons in each one, because the periodic table took all that information and it told us exactly what we got here. So let's take a look. For example, suppose I was looking at magnesium, right? Well, magnesium is in group number 2, so everybody in this column right here is going to have a valence number of 2. I know that. If I go way over here into the halogens, right, this is group number 7, right? That tells me that all these guys have a valence number of 7. Really, really simple. There's carbon over here. Everybody here is going to have 4 valence electrons. The highest number we could get to would be way over here. That's going to be 8. And the smallest number we could have would be the first column here, which of course is going to have 1. All right, let's go ahead and take a look how this would work. So, the octet rule. So the maximum number we could have is 8. 8 is what we call a full atom. So it's very, very happy, very stable. That's why those noble gases don't react, because they've already got their 8 electrons. Now here's what Lewis dot structures look like. You first of all put in the element. Now I've just made up an element. Let's call it element A, right? I don't know what element A is. We'll just make it up. And I've got 8 positions, right? And I've numbered them in the order you want to put in your electrons. So start over here in 1, then go 2, 3, 4. Then if you had 5, you'd start to pair them up, right? So then we'd start putting the 5th one in here, the 6th one in here, and so on, and you'd pair them all up. Now, this is going to be really important because we'll learn later on that single electrons want to get paired up, and that's why they bond with things. Hey, let's go ahead and try a couple of examples to see if we can do it. How about phosphorus? Phosphorus. Now, phosphorus is in column 5A. So if I look back on my periodic table, let's see, where's phosphorus? Ah, there it is right there. Just like nitrogen, it's in column group 5. So I know that it's going to have 5 valence electrons. Let's go ahead and put them in. Now, sometimes books have you put them in as little X's. If you feel comfortable with X's, that's okay. Most of the time, they like to put them in with dots. So let's go ahead and put in 5. So here's how we do it. There's 1, 2, 3, 4, and 5. So we pair it up. So we ended up with 1 pair here and 3 singletons. And that's going to tell us a lot about who it's going to want to make ionic bonds with it. Let's try another example. How about boron? Where was boron? Let's take a look. Ah, there's boron right there. Boron is in group number 3. So that tells us that boron had 3 valence electrons here. Don't know why. I have 5. Did I get that one wrong? Let's take a look there again. Boron is 3. I'm sorry, I made a mistake there. Good that I corrected that. So this is in group number 3A, and it has 3 valence electrons. Here we go. 1, 2, and 3. Very, very good. So that is what the Lewis dot structure would look like for good old boron. Okay. Hey, what about those transition metals I've been telling you about? That big block of metals in the middle of the periodic table. Let's take a look at them for one more time. Hey, there they all are. Wow, this big old block in yellow here. These are called transition metals. And if you look closely at the group numbers, they're all labeled not A, but they're group B. And I've been telling you, I'm eventually going to explain that. What's the deal with group B elements? Well, it means that they can vary in the number of valence electrons. Typically, they'll have a certain number, but given conditions, they could vary. That's why they're called transition metals. Let's try one as an example. How about copper? Is that a transition metal? Let's say, there it is right there. There's good old copper. Yeah, it's a transition metal. Okay, so let's take a look and see. Now, it's in group number 1B, which means if it was like the A groups, we would expect it would have 1 valence electrons. If it had 1 valence electron, it would look just like that. Normally, that's how copper is, but there's a fair number of copper molecules that actually have a valence of 2. So if we drew it, we do it like that. Hey, by the way, while we're talking about this, remember, these are just dots, and you don't have to put them in these places if you didn't want to. So I could go ahead and draw copper like that if I wanted to, right? Or I could draw copper like that if I wanted to, right? Let's not get hung up that it had to be in these positions. It's all basically the same. I could go ahead and draw copper like that if I wanted to, right? The important thing is it has 1 dot, right? So you don't have to worry about that. Okay, this is going to really explain to us how we can start putting together molecules that come together in what we call ionic molecules.